Hello everyone, welcome you again on my YouTube channel. In today's video, I will be discussing about ground level ozone and its impact. I have selected this topic because recently in the Indian Express this news article was published highlighting the city's high on toxic air this summer. The summer of 2022 is one of the hottest in India's recorded history, witnessed widespread increase in the level of ozone gas at ground level and making the metro cities more toxic according to the latest analysis. So this phenomenon of increased concentration of ozone at the ground level is also termed here ozone exceedance. So there are 16 stations in Delhi NCR in this summer. This year was exceeded the daily standard of ozone concentration, and ozone exceedance in the top cities recorded like in Delhi NCR, Mumbai, Kolkata, Hyderabad, Chennai and Bangalore. So we will start discussing about ground level ozone, but before that we already know that the ozone which is beneficial for us, which is already present in the range of 10 to 50 kilometers in the atmospheric layer, which is stratosphere, which help in filtering or preventing the reach of harmful UV rays to the earth's surface from the solar radiation. So now this ground level ozone is not a natural pollutant, it is a man-made pollutant. It is also categorized under secondary pollutant, and this ozone molecule is highly reactive at the ground, and we categorize generally this air pollutant into primary and secondary pollutant. So primary pollutant are those pollutant which are already having some identifiable sources where these pollutant are generated and could easily be identified, but the secondary pollutant are those pollutants which are generated due to the chemical reaction in between the existing primary pollutant in the atmosphere. For examples, hydrocarbons, oxide of nitrogen and other reactive elements in the presence of sunlight. So ozone is a major component of photochemical smoke. Photochemical smoke is another example of secondary pollutant, which is also chemically known as peroxyacetyl nitrate, which is generally formed in the summers, and it's also known as summer smoke or oxidizing smoke because the major component in this ozone and the oxide of nitrogen and the other free radicals, hydrocarbon in presence of sunlight. This particular reaction lead to photochemical smoke, which is really very hazardous for the atmosphere. So ground level ozone gives photochemical smoke its unpleasant odor. Ozone is a pale blue gas soluble in water and some non-polar solvent with a specific sharp odor somewhat resembling chlorine bleach. So peak ozone level is observed typically during the warmer time of the year. Now the sources of these precursors which lead to the generation of ground level ozone, we can categorize into rural and urban sources. So rural sources generally include burning of agricultural residues in the field, in the open, like rice and wheat straw is a very common agriculture practice, and this lead to the emission of volatile organic carbons, carbon monoxide, oxide of nitrogen. And in urban areas, vehicle exhaust, heavy industries, power generation, small scale industry, brick kilns, resuspended dust on the road due to vehicle movement, construction, transportation activity, open waste burning, combustion of various fuels for cooking, lighting and heating. Additionally, seasonal influences are there. So it could be that there will be the variation in the concentration of the pollutant level depending upon the seasons, winter or summers, or maybe in the monsoons, and also from the dust storms, forest fires, open field fire during the harvesting season. Now specifically the chemical reaction which lead to the formation of ground level ozone, which include the reaction between oxide of nitrogen, which is shown in this figure, oxide of nitrogen and volatile organic carbon in presence of sunlight, it leads to ozone formation at the ground level. And other sources like industries operation, chemical solvent which use the process to form ozone, and electronic equipment such as photocopy machine, etc. Now among the precursors, we will discuss here these two important chemical elements which are gases like oxide of nitrogen and volatile organic carbons. So oxide of nitrogen is highly reactive gas which contain of varying amount of nitrogen and oxygen atom in this compound, and it is also a major precursor of ozone formation in the tropospheric layer and from atmospheric fine particulate matter burden as a result of oxidation to form nitrate aerosols. So this particular condition of formation of ground level ozone worsen when the oxide of nitrogen is transformed with the help of other dust particles or chemical element, and it lead to the formation of nitrate aerosols. Nitrate aerosols are generally the solid particles of nitrogen atoms or nitrogen compound which are suspended in air. So these nitrate aerosols are formed due to the combination and reaction between the nitric acid and ammonia. The major sources of the emissions of ammonia and nitric acid. Ammonia is emitted from the organic matter, burning of organic and decayed matter, excreta or biomass burning, and nitric acid may be by the industrial processes. Okay, so this lead to the formation of nitrate aerosol, and these nitrate aerosols which are present in the atmosphere may change the atmospheric chemistry. It may provide the space for the UV solar radiation to the earth's surface, and for the more absorption and scattering of UV rays on the surface, and which lead to the formation of photochemical smoke, and also it enhances the frequency tendency of photolysis among the primary pollutants. So oxide of nitrogen is rapidly oxidized to more toxic nitrogen dioxide, and it is a reddish brown toxic gas with a characteristic sharp biting odor and is a prominent air pollutant. So there are the sources of oxide of nitrogen, which are natural sources include the forest fire, lightning, bacterial activity of soil. Anthropogenic sources include high temperature combustion or internal combustion engine, fossil fuel fire power station, industrial processes, okay, burning of biomass and fossil fuels. The effect, short-term effect may lead to irritates the nose and throat, increase susceptibility towards respiratory infections. Now next is VOCs, volatile organic carbons. So these are the compounds, chemical organic compounds, which are having high vapor pressure, low boiling point and low water solubility, because they are categorized into hydrocarbons. The examples could be aliphatic or aromatic hydrocarbon long chain. They are the simple aromatic compounds which include benzene, formaldehyde, toluene, xylene, etc. And the other group of compounds, the other industrial solvent basically, like trichloroethylene, fuel oxygenated, methyl tertiary butyl ether, MTBE, and byproduct produced by the chlorination in the water treatment such as chloroform. So VOC is used and produced in the manufacturing of paint, pharmaceuticals, refrigerants, cleaning supplies, photocopy, printers, correction fluid, carbonless copy paper, graphics, craft material including glues and adhesives. The effect on the human health, short-term effect may lead to irritation to the eyes, nose and throat, headaches and loss of coordination, nausea and damage to liver. These are the chronic exposure. Long-term exposure may lead to kidney failure or central nervous system disorder. Now, the standard concentration in the ambient air, which is given by the National Ambient Air Quality Standards. So these standards are for ground level ozone. According to the time weighted average of 8 hours and 1 hour, the different limits are given for industrial and ecological sensitive area. For industrial, residential and rural areas, for 8 hours the limits are 100 ppb part per billion microgram per meter cube, which is similar same for the ecological sensitive area. And for 1 hour the limit is 180 ppb. So ecological sensitive areas are the protected areas where it could be the natural vegetation, the protected area, sanctuary, or any ecologically fragile area, forest. Okay, so methods of measuring this ozone concentration in the ambient air after collecting the air samples, it could be measured by photometric technique, or UV photometry, or chemiluminescence, or chemical method. So the impact of ground level ozone on human health. Long-term exposure of ozone may lead to damage to lung tissues. Ozone tend to block the small holes called alveoli in the lungs, aggravating the respiratory problems, shortness of breath, asthma, attacks and coughing. And also the exposure to ozone is linked to permanent health issues such as abnormal lung development, asthma, bronchitis, heart attack and other cardiopulmonary problems. Now impact on crops. On agricultural crops, ozone affects adversely, it damages the plants by entering leaf openings called stomata and oxidizing plant tissue during respiration. Many factors may increase the ozone injury to the plants like soil moisture, presence of other air pollutant, insect, disease, pathogens and other environmental stress. So under ozone stress, it induces the metabolic pathways and reduction in the photosynthetic protein formation, and which will lead to impaired reproductive development of crops. So the ozone stress may also accelerate the senescence, which is the prevention of cell division, where the cell stop dividing, so it conclusively leads to decreased carbon assimilation and resulting in low biomass and in decreasing the crop yield and modification in the crop quality. So other impact related to ground level ozone is ozone cracking in the car tire gaskets, O-rings is cascade by attack of ozone, and on any polymer processing olefinic or double bonds within its chain structure. Ozone present in the upper troposphere acts as a greenhouse gas which absorbs some of the infrared energy emitted by the earth, which also playing important role in global warming and climate change. Now what are the control measures for ozone at the troposphere? So adoption of BS6 standards, which is again for improving the air quality and surrounding environment and human health and other vegetation. So Bharat stage standards for given for regulating the air quality standards and ambient air quality, and also the first standards and norms were given for petrol in 1991, and for diesel it was given in 1992. So initially during the implementation of Bharat stage of various series, it made mandatory to use unleaded petrol, and also it makes mandatory to use catalytic converters in the automobile engines. In Bharat stage 6, it basically highlights the phasing out of two-stroke engines in the two-wheelers, and also cessation of production of Maruti 800, and also it promotes the use of electronic equipment to regulate air quality and the vehicular emissions. So graded response action plan GRAP for Delhi, it was prepared by MOEFCC after the order of Supreme Court of December 2016. EPCA, which is Environmental Pollution Authority, is responsible for its implementation. It aims to prevent worsening of air quality of Delhi NCR, including ozone pollution. National Clean Air Program NCAP, government launched this campaign to reduce air pollution in 102 non-attainment cities, including ozone pollution. So the non-attainment cities are those cities in India which not fall under the category of which not follow the standards of National Ambient Air Quality Standards. So these are around 102 cities. For example, in Rajasthan, some of the regions are highlighted, cities are highlighted like Kota, Udaipur, Jaipur, Jodhpur, Alwar, and in Tamil Nadu, Trichy and Tuticorin, some of the cities are listed under non-attainment cities under air pollution index, and including ozone pollution. So what is the way ahead for controlling this ozone pollution in atmosphere? Promoting sustainable modes of transportation, use of public transport, and other ways like using cycling, walking along with the electric or CNG vehicles, awareness about the various ill effect of these pollutants in general, and also about the ozone pollution, severity of this pollution level in the atmosphere, effective policies including extensive real-time monitoring infrastructure across the cities. Thank you very much for your time.